Welcome back to another video in physics. In this video on electric circuits, we're going to go over the most important equation in electric circuits, Ohm's law. Now that we understand the variables involved in electric circuits, voltage being the electric potential difference across the circuit, current measured in amps being the amount of charge that flows and a point along the circuit, and resistance, the hindrance to the flow of current, which we measure in ohms. We can put the variables together in what's called the most famous equation in electrical circuits, Ohm's law. What Ohm's law does is it shows mathematically the relationship between the variables. As we discussed in a previous video, there is an inverse relationship between current and resistance. So as the amount of resistance goes up, current decreases. The greater the resistance, the less current that flows through a circuit. There is a direct relationship between current and voltage. The greater the voltage, the greater the current. Ohm's law applies to most materials, and they're called ohmic materials, but there are materials such as lamps, such as light bulbs that are non-ohmic, that don't obey Ohm's law. But like I said, most circuits are going to obey Ohm's law, where the voltage equals the current times the resistance. Ohm's law is a very powerful equation in that it allows us to predict the current if we know the voltage and the resistance of a circuit. Let's try an example using Ohm's law. A typical household outlet in the United States provides 120 volts, a potential difference of 120 volts. And our bodies have a resistance of about 100,000 ohms. We can use Ohm's law to figure out the current that would go through the body if you were to touch an outlet with your body. And so 120 volts divided by 100,000 ohms gives you 0.0012 amps. And this 100,000 ohms for the resistance is if you were dry. What if you were wet and you accidentally touched an outlet to cause that current to go through your body? Let's use Ohm's law again, and this time make the resistance be 1,000 ohms, and this is about the resistance that your body would have if you were wet, because water is a better conductor of electricity. And so if you plug in 1,000 ohms, you're going to get a current through your body of 0.12 amps. This is enough current to kill the human body, so please be careful around your electrical outlets at your house, especially if you have small children at home. Ohm's law is a very important equation, and we'll be using it in this class as we study electric circuits to solve for voltage, if you know the current and the resistance. We'll use it to solve for current, if you know the voltage and the resistance, and we'll use it to solve for resistance, if you know the voltage and current. And remember, the units for voltage are volts, the units for current are amps, and the units for resistance are the ohms. And like I said, this is the most important equation that governs electrical circuits. So it's an equation that you can memorize. I like to tell students that it's not a fir tree, it's a ver tree. Or hopefully you never have to go to the hospital and put an IV in your arm